Hey everyone, Mr. Cummings here, and in this video we're going to be looking at calculating the total momentum of different systems. So when we're calculating total momentum, we're going to use the symbol sigma p. So p, lowercase p with the vector above it is our symbol for momentum, and then the sigma means the sum of. So the total momentum symbol is just going to be sigma p. And so the total momentum of a system is equal to each object's momenta added together. Since momentum is a vector, we do need to keep track of the signs of each momentum term when we're summing them up. So if we have positive right being, or positive x being the rightward direction and negative x being the leftward direction, if an object is moving leftward, it'll have negative momentum, and we want to make sure to include that negative sign when we add them up. And then while systems can have any number of objects in them, we can have a system incorporating billions of objects in them. We're typically, in this course, going to be limited to systems where we have 3 or fewer objects that we're dealing with. So take a look at our first example here, and we're not going to use numbers in this example. We're just going to write an expression. But we have cart A initially traveling leftwards towards cart B that is initially at rest. So I'm going to go ahead and kind of sketch and visualize what exactly is going on here. So we have cart B on the left that's at rest, and cart A is on the right, and it's traveling leftwards towards cart B. So now to write the expression for the total momentum of the two-cart system before the collision, we just have the total momentum initial is going to be momentum of object A plus momentum of object B. And the momentum for each object is just going to be mass times the object's velocity. So we'll just get ma times va initial plus mb times vb initial. So now after the collision, we'll do the exact same thing, and we'll just use f for the final subscript. So we'll have the same equation, ma times va final plus mb times vb final. Something to note here that both carts might have momentum after the collision, but in our initial total momentum, cart B does not have any velocity, so we could actually drop that term if we wanted to on the initial total momentum. So now we're going to look at example 2 with numbers, and so we're going to visualize the text in this problem. So we have cart A, which is a 0.3, which is rolling rightward, and then cart B, which is going to have a mass of 0.5 kilograms, and that's initially rolling leftward. So they are rolling towards each other, and they're on a collision course. So the next step is where you want to make a little variable bank showing all the information that the problem gives us, including numbers that the problem tells us that aren't given in a number, such as like at rest would be v is 0. We don't have any of those in this case. But as we're writing this down, we do want to make a special note here that, again, we're dealing with momentum, so the directions matter and the signs matter. VA is moving rightward, which we'll call positive, meaning VB initial should have a negative 0.5 meters per second velocity. And now next, we'll go ahead and just use the total momentum equation, which is just the total momentum initial is each momentum initial added up. And so we'll write that and expand it. And finally, we can plug in the numbers for each term and then multiply out mass A times VA initial, multiply out mass B times VB initial. Go ahead and distribute that negative sign so that it becomes a subtraction problem. And then we should be able to work through this and get to our final answer for the total initial momentum. So we get 0.45 minus 0.25, and I'm dropping the units here just because it can be inconvenient to write, but we do want to add the units at the end. We get the total initial momentum is 0.20 kilograms meters per second. That'll be our final answer here. And that's it on this video on calculating total momentum of a system. Thanks for tuning in, and I will see you next time.